Here's another example from section 8.2, and it's again from the exercises in section 8.2. This is problem number 15 from the textbook about foreign language. It says, according to a study done in Wakefield, done by Wakefield Research, the proportion of Americans who can order a meal in a foreign language is 0.47. So it tells you proportion. It does not tell you any information about the standard deviation, and so that tells us that we're talking about a proportion here. It says, Part A, suppose a random sample of 200 Americans is asked to disclose whether they can order a meal in a foreign language. Describe the sampling distribution of Americans who can order a meal in a foreign language. Be sure to verify the model requirements. So in order to describe the distribution, the first condition is the shape. We want to see if we can say that it's normal. The first check is to see if the sample is less than 5% of the population. So we're trying to see if 200 is less than 5% of the population of the United States. They don't tell us what the population is, so we can't physically calculate this. All we can do is think that if we have millions of people in the United States, is 200 less than 5% of that? Yes. So sometimes it's just to think about a question. The next example, I'll show you how to physically calculate it. And remember, the second condition is to check that this is greater than or equal to 10. So my sample size is 200, my proportion is 0.47, and 1 minus 0.47 is 0.53. Let's crunch that number. 200 times 0.47 times 0.53. That gives us 49.82, which is definitely bigger than 10. So we've checked the conditions to make sure that the shape is approximately normal. So we can safely say, yes, the shape is normal. The center will be 0.47. And the spread, we'll have to calculate ourselves, the square root of 0.47 times 0.53 over the sample size of 200. And that is approximately, let's see, 0.47 times 0.53. Remember, I'm getting 0.53 from doing the subtraction in my head. 1 minus 0.47 is 0.53 over 200. Oops. And there it is, 0.0353. And you could draw a normal curve and label it if you wanted to. I'm not going to require that for this because I think we're getting used to how to draw it. It would be centered at 0.47, and that would be your standard deviation. All right, part B. Fold this up. Part B says, in the sample obtained in Part A, so using what we learned in Part A, what is the probability that the proportion of Americans who can order a meal in a foreign language is greater than 0.5? So we'll do a normal CDF. Greater than 0.5 would go from 0.5 to infinity. The mean is 0.47, and the standard deviation is what we just calculated. And let's see what that gives us. Normal CDF, 0.5 to infinity, with a mean of 0.47, or average proportion. And the standard deviation, we'll type in and let the calculator calculate it. 0.1976. 0.1976, or about a 20% chance of that happening. And part C, would it be unusual that in a survey of 200 Americans, 80 or fewer can order a meal in a foreign language? So this time they did not give us a percentage or a ratio. We're going to have to calculate p hat 80 over 200 ourselves. 80 over 200 is 0.4. So that's our sample proportion. So it's 0.4 or fewer. So normal CDF, that would go from negative infinity to 0.4. Again, with the same proportion and the same standard deviation, the square root of 0.47 times 0.53 over 200. So you could hit second enter and just change that to negative infinity and you'll have to insert 0.4. I don't know if you like messing all around with the inserts and deletes. If not, just run a new function. But you can change it to -10 to the 99 to 0.4 with 0.47 as the proportion and the same standard deviation calculation. And that gives us 0.0237. Is that less than 0.05? Yes, it is. So is it unusual? Yes, it is. So again, anything less than about 5% is considered unusual. So hopefully this is coming together, seeming a little repetitive maybe, because it is very similar to Chapter 7. A couple more examples. The next example is just practicing calculating the normal conditions. So I'm actually going to work this on this page. So for each of these problems, we want to describe the sampling distribution. And this time it tells us that the size of the population is 25,000. So I'm going to actually divide this into 4 parts because there's 4 problems. So on problem number 7, we have to do 3 checks. We have to check the shape, and then the center, and then the spread. I'm actually going to switch to a thinner writing utensil so you can see. Shape, center, and spread. So for number 7, the shape, we're going to have to check this condition. And because they gave us a population size, we can now physically check this condition. And we'll do that for all 4 of them. So for number 7, n is 500, p is 0.4. I would leave 1 minus p to be 0.6, and let's see what we get. You get 120, which is greater than or equal to 10. And then let's make sure that 500 is less than or equal to 5% of 25,000. So what I do in the calculator is I do 25,000 times 0.05, and that gives me 1250. So 500 is less than or equal to 1250, and I can put another check. That way I can check that the shape is normally distributed. The center will just be at 0.4. That one's easy. And then the spread, we'll have to do the square root of 0.4 times 0.6 over 500, which is approximately 0.0219. So the shape takes a minute because you have to do both checks. The center is easy, and the spread is just the standard deviation calculation. Let's try that again for number 8. So it's the same thing for each problem. So number 8, again we want shape, center, and spread. That's what it means to describe the sampling distribution. So for shape, I'm going to do the same thing. I'm going to do n times p times 1 minus p and see what I get. 300 times 0.7 times 0.3. I get 63, which is greater than or equal to 10. Then I'm going to do the other check. Is 300 less than or equal to 5% of the same population size? So I've already done this calculation and got 1250. And 300 is less than or equal to 1250, so I'm good with my shape. Center is easy. It's going to be at 0.7. And the spread will be 0.7 times 0.3 over 300, which is approximately 300, which is approximately 0.0265. So same idea for number 9 and 10. Number 9, we want shape, center, and spread. Shape, we want to do this time 1,000 times 0.103. I have to cheat on this one. 1 minus 0.103. which is 0.897. We got to make sure that that is greater than 10. So 1,000 times 0.103 times 0.897. I got 92.391. So that's definitely greater than 10. And then I just need to make sure that 1,000 is less than or equal to 5% of the population, which again, we've already done that calculation. Is 1,000 less than or equal to 1,250? Yes, it is. And then our center is easy. Our center is at 0.103. And then the spread is 0.103 times 0.897 over 1,000, which is approximately, hopefully this is making sense, 0.0096. So it's just exercising or practicing running these calculations. Kind of a pain. I don't like doing it. It's just a way to make sure that we're meeting our conditions and describing our distribution. So finally, number 10. We're going to do shape, center, and spread. Shape, we're going to do 1,010 times 0.84 times 0.16. Let's see what that gives us. It's 135.744. Well, that's definitely greater than 10. And then we'll make sure that 1,010 is less than or equal to 5% of the population size, which again we've already done. Is 1,010 less than or equal to 1,250? Yes, it is. The center will be at 0.84, and the spread, hopefully this is getting easier, 0.84 times 0.16 over 1,010, which is 0.0115. So this is just practicing the shape, the center, and the spread. The shape's going to take you the longest and be the most tedious. Center and spread are pretty straightforward. All right, one last example just to make sure we're good. About credit cards. It says, according to creditcard.com, 29% of adults do not own a credit card. Says, suppose a random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution for this proportion. So because they gave us a percentage, we know we're talking about proportions. So for part A, we're going to do like we just did, shape, and then we'll do center and spread. So for shape, we're going to do 500 times 0.29 times 0.71, and let's see what we get. 500 times 0.29 times 0.71. That gives us 102.95, which is greater than or equal to 10. Then we will do 500, make sure that's less than or equal to 5% of the population, which they don't tell us the population size, so we just have to think about it, and we can say yes, that is true. So our shape is normal. Our center will be at 0.29, and our spread will be 0.29 times 0.71 over 500, which is approximately 0.0203. So hopefully this is easier to go through. Alright, so really we just need the center and the spread to help us through the rest of the problem. So question B says, what is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So we'll do a normal CDF, more than 30%, so we'll go from 0.3 to infinity with a mean of 0.29, and type in the full standard deviation formula. I know it's a pain, but it saves you from being off by a decimal. My students have complained that the computer is so particular, so you don't want to round, you want to put in exactly what you're looking at so that the computer will accept your answer. And if you did that right, you should get 0.3111. It's about 31% chance of that happening. And part C, what is the probability that in a random sample of 500 adults, between 25% and 30% do not own a credit card? So again, normal CDF. This time we have the lower and upper bounds, 0.25 to 0.3. Same mean, same standard deviation. I know it's a pain, but do not round that off. So normal CDF, 0.25 to 0.3, 0.29, and then the square root of 0.29 times 0.71 over 500. And I got 6646. Second digits is 6. There we go. And finally, part D, would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? In this situation, they don't give us the percentage, we have to calculate it ourselves. So P hat would be 125 over 500, which is 0.25. So that or fewer, so we'll do normal CDF. Negative infinity, oh, can't see that, negative infinity to 0.25, again, same mean and the same standard deviation. And that will be normal CDF. You should be really good with normal CDF now. If you don't like normal CDF, then you'll have to calculate this using the z-score formula and then looking it up in the chart, which most students do not like doing. You should get 0.0244, which is less than 5%. Therefore, it is unusual. So the answer to the question would be yes. So again, these exercises get very repetitive. Chapter 8 really is only about a few things, and it's just practicing. The main idea here is to know how to check your conditions and to know that the standard deviation has been adjusted. Other than that, the normal CDF part is just like Chapter 7. So it's a lot of practice and not a lot of new material.